Velocity. We'll be relating velocity in this calculus unit, and basically velocity is the distance a particle travels. So you've probably heard the term velocity used in your physics classes, and we're going to now relate it to calculus. So some notes here on velocity are that the function represents the distance and height of the particle. Derivatives represent velocity of the particle. So when does the particle hit the ground? Well, that's the zeros or roots of the function. So we would make the function equal 0. And when is the particle not moving, or when has it changed direction? You'll be taking the first derivative of the equation and making it equal 0. So here we have an example. It says the position of a particle moving on a line is given by this equation, where it's measured in seconds and f of x is in meters. Determine the velocity after 1 second. So if I'm going to determine the velocity, I need to take the derivative of f of x, and the derivative of f of x, we get f prime of x equals 3x squared minus 18x plus 24. And if I need to calculate the velocity after 1 second, I'll be substituting 1 into the derivative for x. So if I substitute 1 into f prime, do my calculation, I get 9 meters per second. In part B, it wants the velocity after 10 seconds. So still using the derivative of f of x, I substitute 10 into f prime. Because velocity, how do I find velocity? I have to find the first derivative and substitute the value in for x. And this time it's 10 seconds. Do my mathematical calculation and I get 144 meters per second. So when is the particle at rest? So this is the same equation. So when is the particle at rest? It means that it's not moving. So I need to find the zeros of the derivative. So if my derivative is 3x squared minus 18x plus 24, I need to factor the equation and find the zeros. So I'm going to remove a GCF of 3 out front, and I factor my trinomial of x squared minus 6x plus 8. So my numbers that multiply to give me 8 are 4 and 2, and I need them both to be negative. Solve for x, so my x values are 4 and 2. So when is the particle at rest? It's at rest at 4 seconds and 2 seconds. So the next question asks, when is the particle moving in a positive direction? Well, I know I have my zeros at 2 and 4 seconds. So from my wriggle graph, I've chosen numbers on either side of 0, 3, and 5. And I'm going to plug these numbers into the first derivative to find out whether it's positive or negative. Because you have to remember, this is kind of a particle floating in the air, and it does change direction. So if it's moving forward, it's going to have a positive value. If it's a negative value, then it's moving left in the negative direction. So it's a particle that's moving. And if I sub in 0 into f prime, I get a positive value. If I sub in 3 into the derivative, I get a negative value. And if I substitute 5 into the derivative, I get a positive value. So when is the particle moving in a positive direction? From 0 to 2 and from 4 to infinity. So remember, we cannot have negative time. We can't have negative distance. So we cannot go past 0. You can't go into the negative numbers because a particle is basically moving in quadrant 1. Find the total distance the particle travels in the first 5 seconds. So in order to do this, I need to find the distance within each section. So from 0 to 2, I sub in 2 into the original equation, and I get 20 meters. From 2 to 4, I'm taking the absolute value of it because I can't have negative distance. So I substitute it in, and it's 4 meters. From 4 to 5, substitute the values into the original, and I get 4 meters. So my total distance for each section, 20 plus 4 is 28 meters.